what we've got here is a smart water metering system which basically measures the flow of water constantly in real time, and it's comprised of at least four circuits. As you can see here, circuits A, B, C and D. Circuit A drives the transistor, the base of the transistor in circuit D over here, and circuit B facilitates the operations of both circuit C and D, whereas circuit C powers the Arduino and the LCD display over there, as you can see over there. Circuit A is comprised of two operational amplifiers, A and B, and either of them have been configured to have an amplification of 2, and for circuit A it has got an extra feature of an amplification 3. What happens is that the amplifier receives an input voltage of 5 volts from the Arduino, which is halved and then amplified to a value that then drives the base of the transistor in circuit D. We know from our understanding of ideal and non-ideal amplifiers. For ideal amplifiers, the input offset voltage is 0. That is, when there are no inputs going in to the amplifier, it has got to give an output of 0. But since we are not dealing with an ideal amplifier in this case, we would expect the opposite, and that's what we see here. There are no inputs, but we see an output voltage on the voltage display of 3.83 volts. And so to counter this effect, I've tried my best to reduce the value of the voltage amplified down to 2 as minimum as possible. And so see what happens when we power op amp A. Before we go further, notice two LEDs. There's the green one and the red one. LED the green, indicates that there is voltage coming in from the Arduino into op amp A, and LED red indicates that voltage is going into op amp B. See, the light comes up, and notice the value changing when we look at the voltage output there. We get a voltage amplified of 5.50 volts. It's expected to be at least nearly or above 6 volts, but the amplifier in its working operation takes out some voltage out of it. And so what happens now? We see